Welcome to the final video lecture on transformers. In this video lecture, I will look at how I will explain you how we can find the parameters of a transformer equivalent circuit. So this figure 25 shows the equivalent circuit of the transformer. So here you have the primary impedance, secondary impedance and the magnetization branch impedance. So in order to find out the parameters, we perform two experiments. One is the open circuit test and the second one is the short circuit test. First, we will look at the open circuit test. In the open circuit test, we are going to disconnect all the loads which are connected to the secondary winding. We connect the primary voltage source and the voltage would be equal to the rated voltage. We measure the voltage applied to the transformer, current flowing through the transformer primary winding and the power consumed by the transformer using a wattmeter. Now when we disconnect all the loads, the secondary current is going to be 0. So if the secondary current is 0, then the primary current IP1 would be 0 in the circuit. That means any amount of current drawn from the supply IPT would flow across the primary winding impedance and the magnetization branch. Therefore, the input current IPT is going to be equals to the magnetization current. Now we can compare the impedance of the primary winding and impedance of the magnetization branch. The impedance of the magnetization branch is going to be much higher than the impedance of the primary winding. Therefore, we can neglect the effect of the primary winding impedance. Now we can have a simplified diagram for our test circuit. So we have the applied voltage Vt, then we have the voltmeter, ammeter and wattmeter, and the output of the wattmeter is connected to the transformer. The transformer under open circuit test can be represented by these two elements, magnetization branch. So we have reactance and resistance in parallel, so we can write the equation for impedance 1 over Zm is equals to 1 over Rc plus 1 over Jxm. So Zm is the impedance, so we can write equations for the susceptance which is equals to 1 over Zm. Now we can write the susceptance as Gc minus Jbm. In polar form, magnitude of Im and angle minus theta. Now in the experiment, we will measure the open circuit voltage VOC, current IOC and active power POC. If we divide the current IOC by voltage VOC, then we will get the magnitude of the susceptance. For the active power consumption, we can write this equation. POC is equals to VOC times IOC cos theta C. So from this equation, I can find a value for theta C. So I have now found magnitude of the susceptance and the angle theta C. Now I can utilize this equation. Gc minus Jbm is equals to magnitude Ym minus angle theta, angle minus theta. So from this we can find out Gc and Bm. Thereby I could find the magnetization reactance Xm and the resistance representing the hysteresis and eddy current losses Rc. So from the open circuit test, we would find the parameters in the magnetization branch. Then the next experiment is the short circuit test. In this case, we are going to short circuit the secondary terminal. So the voltage in the secondary winding would be 0, but there would be a finite current. So again, we apply a voltage by means of a source to the primary winding, and we connect a voltmeter, ammeter and wattmeter to measure the applied voltage, current flowing through the primary winding, and the power consumed by the transformer. Now one thing we have to be careful is that we are short circuiting the transformer, so we have to make sure that the current rating is not exceeded in the testing condition. So in this experiment we will start increasing the voltage applied to the primary from 0, and we will observe the secondary current. So we are only we gradually increase the input voltage and see how the secondary current is going to vary. When the secondary current reaches the rated secondary current, then we will stop increasing the primary voltage. Now when there is a current flowing through the secondary winding IST, there will be a current flowing through the primary as well, IP1. Then there will be the magnetization current. So the addition of IMT and IP1T is going to make the input current to the transformer IPT. Then when we compare the current flowing through the IP1T and IMT, IMT is going to be much small, therefore we can neglect the magnetization branch in the short circuit condition. So when we do that, this would be the reduced circuitry. So we can now write an equation for the total impedance referred to the primary winding. So that would be the primary impedance plus the secondary impedance referred to the primary. So we have Rp plus Jxp plus n squared times Rs plus Jx. So we can rearrange the terms, and we can put the resistive component together and reactance components together. So Rp plus n squared Rs is the resistive component, which I can represent with Req. Then reactance component Xp plus n squared Xs can be presented with Xeq. So the total impedance is ZSE is equals to magnitude Zeq and angle theta. During the experiment, we measure the applied voltage under short circuit condition VSC, current absorbed from the supply ISC, and the active power consumption VSC. So similar to the open circuit test, we can find out the magnitude of the total impedance by dividing the voltage by the current. Angle can be found from this equation, cos theta cos inverse PSC over VSC ISC. So now we have the magnitude and the angle, therefore we can find our EQ and XEQ value. So we can find the total winding resistance of the primary and secondary referred to the primary winding, and the reactance component of the primary and secondary referred to the primary component. However, you won't be able to separate the primary winding resistance and the secondary winding resistance, primary leakage reactance and secondary leakage reactance. So in this video lecture, we looked at how we can estimate the parameters of a transformer. So we discussed two experiments. First one is the open circuit test, second one is the short circuit test. So in the open circuit test, we could find out XM and RC components. In the short circuit test, you should be able to find out the resistive component of the winding referred to the primary, and reactance component of the windings referred to the primary. So with that, I have concluded all the sections that I need to cover under transformers. So these are the references that I have used, and I will conclude the video lectures on transformers. Thank you.